Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Okay, hey everybody. I hope you've all had a nice weekend. Mine was pretty busy actually because I'm trying to finish this Tessellation tutorial. Well, I'd like to finish it by Thanksgiving, which is this Thursday. But I don't know. The tutorial turned out to be a bit longer than I expected, so we'll see if I can get it out in time. But anyway, so yeah, I spent a lot of my free time working on that, and also yeah, we're gonna work on some stuff for it today. So last week, some viewers might remember that I worked on, or I tried to make a system to make animations in Unity, because there's a lot of like math in this tutorial that I kind of need to explain or visualize somehow. But it turns out the system I had before didn't really work very well, or the system I was thinking of, because it's better for just like a two-state animation. So for a long timeline thing, I made this new system, but I think it turned out pretty well. Like for example, this animation is kind of explaining how to do something called Tessellation, which we'll talk about a bit more in the, well, a lot more in the tutorial. But yeah, so this is the kind of thing that you can do with the system I've developed. I'm pretty happy with that. But so today we're going to work on a bit more and try to chip away at some of these other diagrams I need to make. So we're going to work on something called a PN triangle, which is kind of, well, Tessellation is a way to like make curved triangles when you subdivide a triangle so that a low poly mesh can become, I guess, higher poly, and the silhouette will smooth. So PN triangles is another way to do it, and they're a bit more costly, but so okay, so let's see here. I'm referring to my video script. Okay. So let's go ahead and make a new scene, or did I do that already? No. Okay, so this will be PN triangles. All right, and we'll give it our flat skybox I've been using. Where is it? I ported this project to 2021.2 recently, which I still really haven't worked a whole lot with, and I'm just noticing this real-time light map section, but it's completely empty. I need to mess with that system. Okay, so a lot of this, well, basically the entire system works with a system that I call the step manager, and it kind of just takes a bunch of different game objects called steps, and like each step just defines like a animation state, and so we can smoothly interpolate between them. And so we'll just have a start step here, and then we can add more as needed. Okay, and yeah, this system heavily uses Freya Holmer's shapes library, so I definitely recommend that if you want to do something similar. Okay. All right, so let's see. I want to place these in the world, if I remember right. These coordinates look pretty good. Okay, so yeah, we have a triangle. And I'll make it semi-transparent. Okay, and then I have a script. Let's do it this way. And then this will be the, I guess, semi-transparent. And I have a script that will draw a border around it. Okay. So to do that, we need to make a line. And if we just create 3 lines, the script I think will be smart enough to set them around the corners. Okay. Yeah, so I think that thickness is pretty good. I want them to be volumetric 3D, which is the reason why we're having to do lines instead of just using the built-in outline system for our end shapes. Okay, so now we can. The reason I want to do this is because we're going to have to like look at the system on its profile, and so we want the lines to be or have volume. Okay, so let me think here. Okay, so for how this works basically is we need to define a bunch of control points along the edges of the triangle. So okay, so I guess I'll set those up. Or visualization of them anyway. Okay, so let's have and I have a script that will place them at a barycentric position. Okay, so yeah, I can put the triangle. All right, so corner A should be a barycentric coordinate 0, 0. And then we'll have corner B and C. Okay, so if we just test this. Yeah. Okay, so corner A is... Oh, I gave them all the same barycentric coordinate. But so the first point should actually be up here, right? Oh, okay, yeah, they're 0, 0, so there we go. Okay, yeah, because it was actually at the final point. Okay, so let's check again. Okay, so I actually want it to wind clockwise, so I think I'll change the order here. Or actually I'm looking on it from the wrong side. Okay, so yeah, this is the correct way. Okay, so it does go around clockwise. Okay, so I think what I'll do is place a shapes sphere on each of these points. And I don't want to like parent them to this because probably they'll need to change position. Okay, so let's see, control points. it could be. Yeah, I need to make all these opaque actually, so that they'll draw in the correct order. Okay. Radius, let's do 0.25. Okay, and this will be the corner A sphere, so and then if I do this, my system will have it always start parented to this transform, and then if I ever need to animate it, I can add a new step to it. So yeah, if we press play, it's at that corner. Okay, and then let's go ahead and color code these. Okay. Oh yeah, I actually want the camera to be orthographic. Okay, so now we need to add, so for this system, there's also points, like there's 2 points on each edge and then 1 point in the middle. So you can kind of think of it, you know, like a cubic Bezier curve has 4 control points, so it works the same way for this system, because we're basically kind of making a Bezier curve for each edge, and then we interpolate between them to make a triangle surface from it. That's what this system tries to do anyway. Okay, and I think, let's say this is on the edge between A and B, but closer to A. And same for all this. And then I'll go ahead and make the center point. Okay, so the coordinates of this one, okay, this might take, so okay, so if it's on the edge AB, it's, so we want this, the C barycentric coordinate to be 0. So the other ones need to be like 0.6 and 0.3. So okay, I'm just going to test to make sure that's okay. Okay, yeah, that's right. And how do we want to color these? I guess it should be orange, because between the yellow and red ones. Okay, now I've got to name all these again. It's okay. And then the center. Okay, so that one is good. BA. Oh, except I haven't actually set up all the barycentric coordinates yet, have I? Oh yeah, by the way, last stream, I know that my audio was a little strange, so I've tried to fix it, but let me know if there's any weird like reverb or clipping or something. Okay, so this one is exactly the same, except it's reverse, so it's more weighted towards the edge B. And then C is always or barycentric coordinate, they always add up to 1, so you can get the third coordinate just by taking the difference, or 1 minus the first 2. Okay, so let's make sure. Okay, there's a point around all the edges. And then this last one is in the middle center, so it's just 1/3 for each. Okay. Alright, so now let's color these. So I guess AB, I mean, if I really wanted to, I could find like exact hues, but I guess this one will be more yellow, because, or I guess it should be more red because it's closer to A. And this one, it's yellow-orange. Okay, so BC, that is green. CB, I guess they're both green, but one is more blue-green. And then these are both purple. Okay, and then the center, I guess, will just be white. Okay, that's fine. Maybe this one could be, or this one could be a bit more orange. Okay, I think that's a little better. Purples seemed a bit more too saturated. I mean, it's not super important, but okay. I think this looks a little better. Okay. Alright, so now we've got kind of good setup for the points, so we can start animating. I think, so in my script, I kind of introduce each of the points one by one. So I think we'll have the corners start out visible, and then we'll add these edges in another step. So I'll just call this edge visible, or edge controls visible, and center controls visible. All right, and so to make them fade in, we can add, oh yeah, there's, oh, this is actually going to be kind of annoying. What do I want to do? So there's a problem, or there's a bug with shapes, I guess. I guess I can just show. So my alpha system, it's supposed to just change the alpha channel of the color, but it doesn't work right with shapes, which we can see. So if I put this in there and then say that, so what this means is that when this step is being transitioned to, we need a transition to have full alpha. So we can see at the first step, okay, it's actually throwing an error. Oh yeah, because the alpha, I haven't actually created one for sphere objects yet. I've noticed that recompiling takes a lot longer in 2021.2. But anyway, so okay, so now when I press start, yeah, you can, I don't even know if you'll be able to see because of OBS, but they're like flashing colors. And I think it has something to do with instancing. So like it just doesn't return the correct color all the time. So I'm trying to figure out, I really don't want to have to set a color interpolator separately for each of these, because then I'll have to, you know, set the color for them individually because they're all different. So maybe what I should do is just have like a check that says cache the starting color. That'll only work like if the color never changes, but okay, so this is going to be also sort of annoying because it's going to be different depending on what object is here, but if cache starting color, okay, I don't even really need it for the text actually, because it has its own alpha thing. Okay, let's see. So if cache starting color, well, I guess we can do it like this. I think I'll just copy it because it's basically the same for all of them. We just change the variable. This is where macros would be nice in C#. Okay, so this should make it work, but also, so if I ever have to change the color of these, we'll have to do it some other way. But I don't think I'll have to change the color. Wait, they're still not right though. Okay, yeah, so if we, yeah, it changed to this peach color. Okay, so this is sort of annoying. Hi Adam Toot, how are you doing? Yeah, it's been a little bit. I don't really like this, but there's obviously some bug in shapes. I don't think it has an update. Oh, hey Gowie, how are you doing? I'm doing pretty good today. Let's see. Yeah, there's not a new version. Well, maybe I know Freya is quite busy right now, so oh well. That's okay. I don't really like adding all this, so I think I'm gonna undo everything I just did. Because it just kind of makes everything messy. And it doesn't work anyway. You just pass exam and you have no time at all. Yeah, I know. Well, it's been a while since I've been in school, but yeah, I definitely remember cramming for exams. I hope they all go well. Alright, well we can't use alpha, so this is sort of annoying, but we're gonna just have to... I mean, the only reason I didn't want to is because now if we use color, I have to set each of these kind of individual because the colors are different for each one. So what I'll have to do is... and then we want full alpha, go like that now. So now I have to do it for each. Okay. And oh yeah, I guess I should have added it for this one as well. This one's easier because it's just white, but okay, so it will pop up. We have the center visible. All right, so let's test to make sure that works. Okay. So next on my script, okay, so I introduce the different corners and then, okay, so then I transition to talk about how to calculate the control points for the edge pairs. Okay. All right, so we need to, okay, so which one is, this is edge A, so we'll start there, I guess. And so the general algorithm is you have a normal vector, obviously for each of these corner points. And if you create a plane that's perpendicular to that normal vector, you can use that to like project different points onto the planes, and then you kind of average between those points to see how the triangle should deform. So I can't get this to rotate the way I want, but basically I want the camera to be edge on to this edge. Come on. Let's move this down to be centered again. Okay, and so now I'll have a transform stepper. Okay, so this will be like a top-down view. And it will start there, and then we'll move to edge AB. Okay, and this will be I think the easiest way might just be to interplay mode. I guess I need to make a new, so view edge AB. And then when we get to this step, we'll transition to this new view. I guess nothing's happening right now. But now if I rotate these, then I can find the one that I want. Oh, I think I'm getting... What? Am I getting gimbal locked here? Yeah, I am getting gimbal locked. Well, how am I supposed to... Let's see. I got this view on another scene, so let me just copy that instead of fumbling around with it. Okay, I thought I tried this, but... So it should happen now. Okay, so it's not quite correct. I feel like I'm even having a hard time getting the correct view in the editor, which is weird. Gosh. Okay. Maybe I just need to do this and then rotate it, the camera anchor, which might make it so the animation is not quite as smooth, but... Or I guess this. So it says... Is that not right? Because... Oh, okay. It was at... Yeah, so that's upside down. Although I guess maybe it won't matter. So if I do this, okay, good. The camera should, yeah, just rotates around. So something like -60. Okay, I think that should be looking straight on the edge. So I guess I just need to add, I think I have an Euler angle. Yeah. Oh, it's not on the right one. I guess maybe it should just be positive 60. Okay, yeah, that is right. It's not centered. Or maybe it's just the screen. I don't know, it's kind of hard to see with all these other points, so we just turn these off. Okay, so it's not centered, so to center it, let's do something like that. Okay. Because distance doesn't really matter in this, since we have orthographic. Okay, so now what I also want to do, I guess, is hide all of these edges when they're not needed. So to do that, we just got to go in here and add a new step. And this is what I was trying to avoid before, because now since these are all different colors, I have to set the alphas separately. But no use complaining about it. Okay, so let's just make sure that this is working. Oh, did I, okay, this is still negative 60, so I need to set it to positive 60, and I also need to hide this corner. Oh. Let's try one more time. And I think just to speed up testing, I'll drop the transition period. Did that work? I feel like the center never became visible. Oh, I didn't add a new one. I just overwrote the old one. Okay, so now what I need to do is draw the normal planes for each of these, which will just be I think just for the sake of the visual, since this is straight on, I think I'll just have lines here instead of having actual planes, because I kind of illustrated the way that the normal vectors and stuff worked before. Okay, so let's see. But I wanted to still define them by a normal vector, because the actual math is going to be using the normal vector. So I guess we can do something like, okay, so we have the anchors. Just trying to think. Do I want to do actual planes? I think that'll just make it more confusing. But so the actual vectors need to be in 3D though. Okay, well, let's just see how it looks. I think I'll go into my other Phong tessellation and grab some of the stuff. I know this tutorial is, or my naming scheme for this was kind of messy, so we'll clean that up. But anyway, I use these for the normal vectors. And so the normal vectors just always point towards these anchors, which is why I've called them a magnet. So this will be for vector A, or point A. Okay, and then back into here, and I'll grab the this plane object. Okay, oh yeah, and then I need an up vector. So just set here and then make it point straight up, which is that. Oops. Oh, except from here, I guess it's on the z-axis. Okay, so now the plane has and up. All right, and I'm just gonna remove or clear out the junk that I don't need. Okay, so we will need this stuff, but for now I'll just remove it. Okay, yeah, and then this script is for when we project a point onto the plane, but we'll probably use something different, so delete it for now. Okay, so let's make sure this displays correctly. Okay, so I'm just gonna walk through the animation. Okay, yeah, I was afraid. See, I don't really like how it does that. What if I set the rectangles like X size to 0? Okay, so then it turns into a line. So that actually will work pretty well. Okay, so yeah, that makes that a little easier. Okay, so let's add these to the other corners. All right, and I want these to have the correct colors. Oh yeah, I just have to set the color in the arrow object, not in the individual pieces. Oh, these should actually be blue because this is the third point. Oh, right, and the other ones are pointing to the wrong magnet. Okay, this looks fine. Yeah, we can adjust. Like the normal vectors, I think might be a little bit pointing like outwards too much, but we can always adjust that. Okay, I can see here that we're not completely like straight on to the triangle apparently because this arrow doesn't fit exactly, but it must just be. Okay, well, it probably will be pretty obvious. So it's either that these are positioned wrong or my camera is positioned wrong. Oh, it's that they're not. Okay, the center of the ring isn't in the correct area. And that's because, yeah, I forgot I offset this triangle. Okay, so let's move that here. Oh, but still offset. Oh. Okay, and now that looks more even. So I don't think it's perfect because it doesn't look completely symmetric. Oh, but maybe this is actually just the sorting order. I think that might be what it is. Because if you kind of look at like the size, well, I guess they're still not the same, huh? All right, let's see. Okay, yeah, they don't go straight through the point, do they? Oh, you know what? My triangle is not perfectly equidistant, so that's probably the issue. So can I fix that? Let's see. So what are the points that I need for this? Oh, not equidistant, equilateral. Okay, that's nice. Okay. I was hoping somebody would just tell me. I mean, obviously I can do the trigonometry, but okay. So 0, 0, 6, 0, and then 3, and the y is the okay. Yeah. So there's not going to be a perfect, but I kind of want things to be equal if I can. Okay, also, yeah, this needs to be in the exact center of a triangle. Okay, so maybe what I should do is do a barycentric anchor. This will find the exact center. And then, so here I just need to set the correct points. So it doesn't really matter what I do here. Okay, so this is half the total length, and then so this is square root, so it's like the square root of half length squared plus y squared. So then I would do some algebra. I don't know. I think I'll figure that out later. I just want to do the animations right now. Okay. Yeah, I think it's good enough for now. But let's see. Okay, so what else? Where was I? Okay, so yeah, I need to have the planes and stuff hide until basically we'll go on the side, then I'll show the planes, and then I'll have them constrict to be just a line, and then we'll project the points onto them. And I might not even need the plane for the third corner, so I'll just turn it off for now. And I don't think I'll have the normal vectors. Okay, so here I just need to add a color stepper. Alright, so let's make a couple more steps. So first we'll show normal planes, and then I guess constrict planes AB to line, and then we'll do the actual projection. Okay, so this will become visible here. And I also need to do a rectangle size stepper. Okay, and so it starts at 0, 0, and then when we show the planes, it will expand to 10, 10. And then when I constrict them to lines, the x component will go to 0. Okay, so now let's do the same thing for the other plane. Oh, it actually should only go to 20. Because I don't want it to be full alpha. Okay, so 10, 10, and then 0, 10. Okay, let's see how that looks. I'm just trying to see if I can really tell they're not symmetric, but it looks good enough. Okay, so that worked. Okay, so now the algorithm is you take, for this point that's closest to A, you project this onto this plane, and then you weight it to be like halfway between this point and the new plane, so it's like right here. And then for this one, you do the other side. Okay, so how do I want to do that? I don't want to move this corner because it stays. We're just kind of like making a control point. So I think I'll just create another sphere that zooms over here, and then to average, we'll just have that one move, and then this one move up to it. Or maybe this will just stick there, and then that one will move up to it. And then that one will disappear, and then we'll do the other side. Okay, so project A to, or wait, project B to A plane, and then project, or move edge, move control edge AB, and then we'll do the other way. So move A to B plane, and then move control edge BA. We'll go from there. I think the next animation will kind of like rotate the camera, and then so you can see all the points, and then all the edge control points will move, and then we'll calculate the center point, which is a slightly different algorithm. Okay, so now I need to make the anchor points. So I have that project to plane, which I think might work. Let's see. Let me see here. I'm going to pull up Tessellation research script or shader just to make sure that it's the same algorithm. If I remember right, it is, but taking a little bit to load. Okay, so we've been streaming for an hour. I think should be able to finish these, I hope. These diagrams take like a lot longer than I was expecting, which is one of the reasons why I've had to kind of crunch a little bit for this video. But I think that they'll add a lot, so I'm okay with it. Okay, so here. Oh, that's a normal vector. Okay, yeah, so they're also adding together the both operations, but basically, yeah, so to project something onto the plane, you subtract the part that's projected onto the normal from the point, which is what this is doing, and then we multiply by the normal vector to have like the direction towards that, and then we average with the position weighted by 2. Is that? Okay, so it's actually averaging with the corner position. I don't know if I put that in the script. It doesn't actually average with that control point position. Okay. Right, so I think that's correct. So this project, or here. So I think we can use this to create the position projected on the plane, and then I'll need to have like an average between points, which I think I already have that, so should be good. Let's see. Project B onto a plane. Let's see. All right, you need to take a break. You're gonna go and stretch your limbs. Okay, Gowie, have a good one. Good luck on my work. Yeah, thank you. I think it's going pretty well. So, yeah, thanks for coming by. Okay, so we need the normal start and the end, which we have thanks to okay, I guess these didn't need to be under that triangle anymore, so we'll put it there. Okay, and then a point on the plane is the corner A. And point start is corner B. Okay, so let's press play, and I think I'm just going to attach a sphere to this and see if it makes sense. Okay, let's shrink it a bit so that it's not quite so big. Oh, it's not. There we go. Okay, so it's kind of out in the middle of nowhere right now. Oh, you know what? Okay, so the problem is it is being projected onto the plane, but the plane is not on this line. Or it's not, the projection is not on this line. So maybe, okay, so maybe I need to keep some perspective so we can actually see what's going on. Don't know why the rotation is being so weird about this. I guess this is a good showcase of how Euler angles can get you in trouble. But unfortunately, that's our only option in Unity. Let's see here. It'd be really nice if it would just go onto this edge, wouldn't it? I guess I could force it to, but then it wouldn't be the actual math. I don't know what I want to do. annotations are not helping. I mean, I guess just for this illustration, I could keep it like this, but then when we zoom out, it'll go to the actual corner. Okay, so maybe for this illustration, I would just manually place it because, yeah, I don't think it's going... I don't want to do the actual math to figure out how to get it to go on the plane by hand, or that's like perpendicular to the view direction. Like, I guess it wouldn't really be that difficult because the normal vector would just be averaged. I mean, yeah, we could do it, but I think we could also just place something. So it's supposed to be like around or projected on the average or on the normal vector. So, oops. What's going on? Put that there. Something like this. Okay, so yeah, I'm just trying to kind of eyeball it. So the normal vector is, if it's pointing right here, should be about the same. Okay, and then it will just like be averaged. I guess the only problem with this now is that since it's directly on this plane, when we average this, because we have to take like 1/3 this position and then 2/3 this position, that just goes straight down. So, well, I guess that's how it's always going to be, actually. So the final point's always on the plane because we're projecting onto the plane, and then we're averaging with the corner point with it, which is also on the plane. So I guess that's fine. So yeah, the control points are always going to be on the normal plane. Oh, I never visualized that until just now. Okay, but anyway, let's adjust this slightly. Okay, so I'll copy this. It doesn't have to be like super. So this will be illustration, project B on A plane, and we'll paste the position I just created. Okay, so now I just need a sphere. So this will be like, I don't know, project point. And this one will just be a sphere that kind of just zooms around as we project things. Okay, so at first it will be on corner B, but we'll actually start it invisible, and then when we project B onto the A plane, it will become visible. Okay, so the next. Oh wait, no way. Well, maybe this will be okay. I think it's slightly messy to put this like on the child of the above object, but this should average with these 2 points. So 1, 2, and then so this project point will then, when we go to the next, it will move there. Oops. Oh, I didn't actually set up this part yet. Okay. Actually, I guess this point should stay for now because it's, yeah, and then the actual edge itself should move. Wait, I keep doing. Okay, so let's make sure I didn't like, I don't know, mess up something there. Okay, so yeah, it moves 2/3. Okay, so that actually worked fine. And then we've got to do the same for here. So this point, okay, well, I guess when we, so I guess this point will disappear and then move over there, and then this will move there, and then we'll zoom to a 3D view, put these in their actual positions, and do the same for all the other ones. Okay, so let's see. Oh, yeah, I shouldn't do it while I'm in play mode. So this up here, project A to B. So in this point, the project point will disappear. Okay, and also we could kind of reuse this, but I think it'll be cleaner if I just make a new one. So BA, because otherwise we might be able to see, we'll either have to make like a step that we don't really need, or we'll be able to see it move where it's not supposed to. So okay, so this one starts at corner A, and then I don't have this point yet, but so this is that for now. So I need to make this illustrate, but for now, I'll just flip the x component, which I know isn't right. It should be like somewhere over here, but and then this one. Oh wait, wrong thing again. Okay, let's just check this so far. Okay, well, so this one went to the wrong point, and then also, obviously, the illustration point's not right, but let's see. Check this part first. Oh, also, yeah, the easing is wrong. Okay, so I need to make sure this point is in the right spot. And again, it really only matters kind of that it looks right in the diagram. Okay, I can live with that. Okay, so let's just check this one more time. Okay, so it works. Okay, so the next one, I guess we'll kind of reveal everything again and zoom out, and then we'll rotate around or something. Okay, so zoom and reveal all. Okay, so first thing I need to do is hide this temporary point again. And then I need to, so all of the control points need to move to the right spot, and then I guess I should make the planes visible, but let's make all the control points first. So this, I'm projecting B onto the A, and then B onto, or A onto B plane. Okay, I wish there was a simpler way to do this, but so C onto B, B onto C, A onto C, and C onto A. All right, and then I need to average each of these also with a corner. So but let's set up all these first. So here, so A onto B, so the normal starts. Okay, I'm gonna have to be careful I do all these right. Okay, so the normal starts on the B, so corner B, magnet B, and corner A is the start. So A, B. Okay, so that's good. Yeah, it's the same letter for the first three, and then the other one for the last one, so I can remember that. Okay, so this one should be B, 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 and then C for the last one. Okay, and then reversed. Okay, so let me just look. B, or B on the A onto B, C onto B, B onto C, A onto C, and C onto A. Okay, so I think that's right. Okay, so now for these, I just need to average the 2 points involved, which would be this and the actual corner. So it would be A corner. Okay, so let me copy the, oh, I guess I could just duplicate. It's gonna have that number at the end, which I guess I'll have to manually go and remove. Okay, and then for each of these, I need to update. Okay, yeah, these are all going to be like rife for bugs, but thankfully it will be really obvious if I get something wrong, so. Okay, so B, D. So we got the letters should match. So this last letter should match the corner. That's what I'm looking for. Okay. All right. So now what I need to do is decide when. Okay, so. Okay, when the camera zooms out, I guess I want to display all of the planes and then move the remaining edge points. Okay, so first off I have to find a good camera angle, which we've seen has been slightly annoying. Let's see. Okay, it seemed like it wasn't affecting it. You know what, this would all be a lot simpler if I just rotated the triangle so that the first edge was here, because then I could just move down. Okay, so maybe what I just need to do is rotate this entire camera thing so that this edge is straight on. So that would be like -60, right? On the y-axis. Or wait, z actually. No. Really? Because the z-axis looks like it's perpendicular to me. Okay. Okay, if you're gonna be like that. I mean, I could rotate the triangle, but I'm afraid it will mess up something I've done, but I don't know, maybe this is just the easiest thing to do. Okay, so rotate this -60 again. Okay, I don't know. This is... I guess my systems don't take triangle rotation into account. Let's see here. Oh yeah, so they only take the triangle's position. Yeah, so it doesn't actually do rotation, which I guess fair enough. So I could add that in. I don't know. It'd be really simple if I could just rotate that camera. So I don't know why rotating it by the Z is being so strange. Okay, so it's working here. So maybe there's some problem with it. It's actually... Oh, it's like 120, yeah. Oh, but yeah, my triangle is not completely equilateral. Okay, so I think that's probably some of the issue. I don't know. So I might mess with the camera some more. I guess it doesn't really matter right now. We'll move there. Okay, and then we also want to reveal all of the planes at this point. So all I have to do is, for these rectangles, I just need to change the width again to 10. And then for the third one, I need to actually reveal it for the first time. So 10 and 10. Oops. Okay, and then at this point I also need to move these edges to be on their actual, like to actually be on the plane, and hopefully it won't be too obvious that I've done that, but So let's see if this looks okay. High five, Belby. How are you doing today? Well, that's not what I wanted to see. Hopefully I didn't lose too much work from that. Okay, so let's see. Did it save? Okay, it did. Oh. Oh no. I had to have saved more recently than this. Really? Okay, I just lost a ton of work. Is Unity good for animation? It's pretty good. I like it because I can script things out. Although, yeah, unfortunately I just lost a ton of work, so maybe that's not the best thing. Okay, I've never had that crash, so of course it happens on stream. Can you make animation anything else? Well, there are other programs, but Unity is what I know the best. Okay. Yeah, I didn't even save stuff I did to do the interpolated points and everything. Okay. You just made your first Unity game? Oh, cool. What's it about? So what did I have here? So view edge. I guess planes. Okay, so view edge, view planes. Planes to lines. Project B to A. Move edge or control edge BA. Okay. Hide project B to A. Project A to B. Move control edge AB. Zoom camera. Now I'm gonna be. I wish there's probably some option I can have it to automatically save when I press play. I thought I had turned that on actually. I don't know what this be. No, I'm gonna press Control S all the time. A side scroller. You drive the cart on the lines and draw lines with the mouse. Oh, that sounds pretty fun. I always like to introduce like mouse controls into platformers and things like that. Oh, okay. Alright, let's try not to get annoyed. These happen. So illustrative project B to A. And then average corner. So let's see. Basically, most of the work I've done was deleted. So this will be projection demo. Do you animate with code? Yeah, I've pretty much animated all this stuff with a script system I've set up. But a lot of it's done with like game components. Okay, so this becomes visible when we project B to A. And then it becomes invisible when we hide it. And okay, so it starts at corner B, and then it moves to this illustrative when we do this. Okay. Similarly, this becomes visible when we project A to B, and it hides when we zoom the camera out. Yeah, this should be quadratic. And then it starts off at corner A and moves to the illustrative when we project. Okay. And as for these edge points, okay, so it starts there, but then it moves to this average point, and this, and then it, okay, we haven't even set up the actual points yet, but okay, and all right, so let's take care of the normal planes now. So this one starts off at 0, 0, and then, okay, well, we don't, I guess while I'm working on it, I might as well. So reveal. What do I want to reveal the planes when the camera is zooming out? I guess not. Okay, so anyway, they first start, I guess I should rename this. Okay. So here, there, it's both 10, and then when they go to a line, we move this to 1, and then they move back to full size. Okay, I guess I can copy this because it's the same for the blue. Okay, and then, oops, that was the wrong one actually, but okay, so it's actually different for this one. It doesn't display until we reveal all the planes. Okay, so let's see how this looks so far. Oh, I set this to 1. It should be 0. Also, did I have like an extra step in there? Okay, so there's an extra one. because nothing happened. Oh, okay. Yeah, so this should be like that. I don't think that's the way we did it before, but it's fine. Okay. So, oh yeah, so that's going to the illustrative point, but that's not correct. But I just want to kind of see. Okay. So I need to figure out where to put this point. So again, it's not going to be exact, but okay. And we'll do the same thing with this other one. I want it to be in front of the line. Okay, so I gotta move it like this. Okay, this will do. Okay, so let's see. Okay, that's good enough. Alright, so now I've got to do all those points again for the projections. Okay. Alright, so actually first we project B to A. So the normal starts at the corner. It has that, and then also starts. The point starts at the corner, and or the plane point is there, and then, but then the point start is there. So now I gotta duplicate this a bunch of times. Oh, okay. Well, I guess before I duplicate, I should make the child object, which has the average. Average with corner. Okay. Okay. 1, 2, 3, 4, 5. Let's project A to B. Just gotta flip everything. All right, and then B to C. Well, I guess know, it doesn't really matter. I did set this up. Okay, let's do that. C to B, just to kind of keep them in order, I think. I'm so annoyed that happened, but okay, and then B to C. Wait, I did that backwards, didn't I? Yeah. And this should average with C. Okay. And project A to C. And finally project C to A. All right, so let's check. Okay, it looks right. Okay, so now when the camera zooms out, we need to move these to their actual positions, and then yeah, just hope it's not too obvious. All right. Okay, oh, we had to move the camera, so that's fine. I don't know how this will look. We'll see. That's not how I thought it would be at all. Oh, I didn't set this up right. Okay, it shouldn't. Oh. I actually think it should still be rotated a little bit because I don't want it to be like straight on. Something like that looks pretty good. Okay. Okay, so let's set this up correctly. And I think also when we zoom the camera, all the planes should just reveal each other because when we did it, the planes as lines just looked kind of strange. So let's fix that real quick. All right, let's see how this transition looks. That was kind of funny. It like flipped completely. Oh, that's really weird. The way that I've set this up is... Okay, we're kind of viewing things backwards because... how did I fix that? If I just got rid of this 180? No. So any value that will give me the right thing I want. Okay, so that is actually better. But wait, am I upside down now? Okay, I guess that doesn't really matter. It's just kind of funny. Yeah, these camera angles are really annoying me. Okay, so what's happening? Wait, I didn't... Wait, it was right. Then how did I... Okay, maybe it was an optical... Or maybe this is an optical illusion. Because what I thought before was happening was the blue point was actually like behind the... Or the blue point was actually in front of the edge. It seems not, though. But then, I guess this is an optical illusion. Okay, yeah, that's funny. This actually looks like it could be a good view right there. So what is this at? And then the rotor is like at 42, okay. I don't know, you can see the right position, but... Okay. that right? Because it feels like now, like if you watch at this point, it feels like it's like going underneath the triangle. Okay, no, it's not. It's just the... Okay, I guess this wasn't such a good view after all. Okay. Maybe I should just hide all the planes. I don't know. They don't really help much, I think. I don't know. I think... Okay, I'm not going to worry about the camera because I think I just need to figure out some better system for it. So we'll do that later. Let's just finish the rest of the animation. Okay, so we'll have a zoom camera step, and then the next is we'll reveal... Okay, well, I guess in the zoom camera step, all the other points will be revealed, and then we'll move other edge, move control, other edges. Okay, so here, this will become visible again on zoom camera. Okay, and then also, okay, so we've got to try find the right transform for this. Okay, so this is the point that's on edge BC, but closer to B. So this is when we project C onto the B. So, okay. This one, all right, I need to make sure all the quadratic easing. Okay, and then this one is the symmetric one. Okay, so thankfully they're in the same order. I guess it'll also be pretty obvious if one of them's not correct, because we can we'll see that move into a weird spot. Okay. Let's just watch that. I guess I should have saved in case it crashes again, but... Okay, is that right? Okay, the only one that doesn't make sense is the pink one. So the pink one should be here. Project C onto A. Okay, so this is wrong, yeah. See, it has the wrong corner right there. Okay. The pink is still not right. Okay, it also has the wrong... Did I forget to set this one up or something? I don't know. Okay, there we go. So all pretty symmetric. Although, yeah, the view, I don't like the view. Okay, so I guess this point will hide the planes and then move on to the next part, which we are trying to figure out what to do with the center. Okay, so let's see here. Ready, center. So this, for the center, you basically average all the control points, and then you average all the corner points, and then you like take a weighted average of that. Okay, so let's see. Average edge points. Average corner points. And then move control center. Okay, so on this phase, we'll hide all the planes. Okay, so here, so 0. And so yeah, we're done with the planes now, so that's nice. And then the center point needs to become visible again. Okay, now how do I want to average or show that I'm averaging all the points? I could like just make a new sphere that goes from each towards the center. I guess that's just what I'll do. Okay, so how am I gonna do this? Average control AB. So this is when we average, oh wait, average edge points. It becomes visible, and then it'll become invisible at some other point in the future. Okay, and this will... Okay, so I need to have another thing here. So this will be the average control. Oh, I guess average edge control, so I should call it. Okay, so this one has 6 points, and it's each of these average with corner variables. Okay, so I need to make sure, since they're all named the same, that I don't like double up. Okay, so 1, 2. Okay, so I did that correct. And then just give them all the same weight. Okay, and then I'll have average corners. Wait, that's just the center because the average corner is the barycentric center. So okay, I don't really need that one. Okay, I do need some script for the weighted average of this. Let's see. So can I figure that out? I think so this is the thing. So if I say that the average edge is E and then the average corner is C, then that would be plus E minus C times 0.5. So that would be E plus E times 0.5 plus R minus C times 0.5. Okay, I think that minus sign is going to mess up. Okay, I think I'm just going to have to have a separate script for this. Okay, let's see. Alright, so we'll do point algebra anchor. So basically I'll where's the average? So we'll have a bunch of points and then weights, and instead of like doing this total at the end, we'll just add the points together. So I can use, well, I deleted the formula I just made, but I can use this form. So it'll be E plus E times 1/2 minus C times 1/2, and that should be the same. Okay, so center control. I mean, I guess technically it's this is the same as E times 1.5 minus C times 0.5. So yeah, I don't need to have it in there twice. Okay, so the average edge control, and then the center point goes there. Okay, so anyway, I did this because this should start at the control point, and then it will move towards this average. Oh, I did this wrong. And this happens when we average the edge points. Okay, let's just make sure that makes sense. Okay, so yeah, that moves. So yeah, all of the points will kind of move towards the center. Okay. 2, 3, 4, 5. BA. BC. DB. CA. Okay. So pretty much all the names don't really matter because this isn't going to really have any mathematical impact, but basically just need to make sure that they start at the correct, or not even that they really start at the correct, but that there's one for each. Alright, let's try that. So they'll move towards the center. Okay. Cool. Alright, so now I need to do the same thing, but for the corners. Okay, so let's do this. So average corner A. Okay, and this one will start here, and it will move to the center. Oh wait, well I don't need to do this because there's already the center point is going to be displayed, so So I guess I don't really even need this phase because this is already going to be on screen. Well, maybe I should do it just to kind of show. I don't know. Okay. Well, I can insert a phase if I need to. Let's just finish this up. So for the last thing I need to do is move the center to the new point. So yeah. Okay, so I can delete that one. And then we'll just have a final cleanup where this all of these. Okay, well these should all be invisible already, but let's go invisible there, but then this last one goes invisible during the cleanup phase. Okay, so it did go farther, which makes sense because it takes 1.5 of that and subtracts just 1/2 of the center point. Okay, and so then we'll want to do like a final camera, I guess, zoom around so you can kind of get the dimensionality of it. But yeah, so this is the control points for the specific triangle. Where'd this blue corner? Okay, I guess I never made it visible again. Okay, I don't need these. Oh, I guess, yeah, they have to stick to that, so that's fine. Okay, so this one should become visible when all the other control points become visible at zoom camera stage. Okay. Oh. Did that work right? Okay. Seemed like something else changed, but all right. So I think besides the weird camera, I think we're done with this. Okay, so let's see if we can tackle the camera real quick. And I think I might just like delete it and start over. let's just do that. I guess the camera doesn't have to be for first. I also probably don't even need this light, but I'll leave it. Okay, so what? I guess let's see. First, this should go -10. Okay, so when I press play, this edge, I would like this edge to be what's first visible. So anyway, okay, so yeah, I can rotate, but it's not, I don't know what's going on because why does it get skewed? Is it, maybe it's not getting skewed, it's just that the triangle really isn't equidistant. Okay, at that point, maybe I should just make a script to make an equidistant triangle. Because this... Okay, well, the only thing is those illustrative points will have to adjust. But that's okay. Make equidistant, or what's it called? Equilateral triangle. Okay. So this will have, I don't know, edge length. Alright, I can actually just do this on a wake. That will make it less likely to cause any issues. Okay, so let's see. So the height or the length. I guess, yeah, the height is what we need to find. So the length of one side is L, which is equal to SQRT. Length divided by 2. So L times 0.5 squared plus height squared. Okay, so square roots, you can or you can remove the plus sign in it, I think. Let's see. I always been a little bit since I have to remember all my square root, what's it called? Identities. Let's see if there's just a good, oh, that's because I think if you add it, I could be wrong. Oh wait, no, that's not right, because 2 plus 2 is 4, so the square root of 2 plus the square root of 2 is not the same as the square root of 4. Yeah, so, okay, so I was wrong about that. So I guess this would be, so this, I just need to square both sides, so L times L equals L times 1.5 squared plus H squared. Okay, so the good thing is I know what L is, so that's not that big of a deal. So this be L times L, oops, minus L times 1.5 squared equals H squared. So then we can just do a square root. Okay. So float H equals math sqrt edge length times edge length minus, okay, let's do this, float half edge length equals divided by 2 minus half edge length times half edge length. Okay, so try dot a equals new vector 3 0 h 0, and then b is half edge length 0, and c is negative half edge length 0. Okay, so the only problem is this isn't going to be centered, but let's actually just see if it makes sense. I guess I'll go here. Okay, so that it does work. And thankfully it doesn't mess up any of the scripts. Okay, so I don't... Are these magnets in the right spot? They look like it actually. Okay, let's just step through. Okay, obviously the camera doesn't move, but so far it looks like moving the camera hasn't messed up anything, so we can just move the camera up. Hi, So Random, how you doing? Okay, well I'm glad to see we made a little progress. Okay, so I think I can just move. Oh, come on. This looks good. Okay, so let's see. The other thing I want to do is, again, it'd be better. Well, okay, on my other diagrams, I've always put A at the top, so I guess this is fine, but I want it, the camera needs to rotate to face the right way, and it's like being a real pain. Maybe if I just like compose a bunch of stuff together. So I have one that rotates the camera around the y-axis and then another one that does it on the x-axis. Maybe that'll work better. Let's try it. Instead of trying to use quaternions, which normally are better, but it's not really working. And then this goes there. Okay, so let's just walk through the animation until we get to that point. And so what I want, excuse me, is rotate. Oh, I'm doing position. So rotate, okay, by 120. Sorry, my voice is cutting out. So maybe my whole issue was really just that the triangle wasn't really equilateral. Okay, so this is not centered anymore, but I think that's okay because it just has to do with we rotated the camera to go a certain direction. So I can just move this back. Okay. I think that will work pretty good. So let's do offset. So we'll start at 2.44, and then I don't know when we go to this. We'll move it to 1 and just see how that looks. Okay, and then same thing. Oh, not position. I want Euler angle. And then when we move to view this, we are going to go to 120. And here, this will be 90. Okay, so it's, oops, it's backwards. Starts. Then. Okay. Not right. So what is wrong? Okay. Let's see here. Oh, again, it's on the z-axis. I keep doing it wrong because I'm used to the y-axis being straight down, but I'm working in a different coordinate system. Okay. Okay, I think that's right, or I don't know, it's hard to tell, but I think, I mean, it does look like it's, oh, that could just be, I was going to say it looks like it's like underground or underneath the triangle, which I guess it kind of is. So should I do -90 then? Yeah. Okay, yeah, that's better actually. I think that. Hey, thanks for the follow. But why? Oh, okay. It's just because I was gonna say, how come this plane, gosh, my mind went blank, is like more visible. It's because the camera's not centered. But can't I? Yeah, actually, like instead of using a position offset, couldn't I just center the camera on the barycentric center of the triangle? Let's try that. Okay, so we'll just stick with that. It looks a little strange when we first start it, but I think it'll be okay. Oh yeah, also it's upside down, so I need to do -90. Okay, and these illustrated points are not right, but we can fix that. Okay, so at this point, we'll want to bring this back out a little bit so we can get a better view of everything. Okay, yeah, this works much better. Okay, and maybe we'll add a little bit of rotation. let's see how that looks. Maybe I went a bit too overboard. I think something like that would be better. So I'll just set it to 90. Maybe at this point I need to bring it down so we can kind of see how those react a bit better. Okay. Do I have... Okay, I do have this ready center, so at that point I can move the camera again. To... Oh, this is the wrong one. I need to do it on the x-axis. And this one we would, I don't know, bring it closer to 90. Try that. And then on the final cleanup, I want to maybe like take a final view around. So let's do one more, I don't know, panoramic. And then this one, we'll just rotate this 360 degrees. So 360 times 90 is 450, I think. How come it didn't work? Wait, did I do it? Oh no. I thought that the Euler angle... Oh, okay, I forgot. The Euler angle is not actually... Yeah, this is kind of one of the issues about working with quaternions is that it doesn't distinguish about 360 rotations. How can I fix that? Hi, Phoenix Fire Row. When will come a new video about outlines? It'll probably be a little bit because I haven't, I mean, it's still in planning stages. But I will hope it's on my short list of videos to make for sure. Okay, well, I guess the easiest way is just instead of making it a 360 rotation, we just make it a 180 rotation. Yeah, I thought that I actually implemented this with Euler angles under the hood, but it's actually quaternions. So... I don't know, I guess that gives a good enough view of what's going on. Maybe we can also slowly pan out here. Oh, I don't want to edit it right now because it won't save. So everything moves really fast right now, but okay. All right, so the last thing I need to do is just update those kind of hacky points, these illustrative points, because they're not positioned by math. Okay, so let's zoom to that stage. So I just gotta find a value that looks good and is roughly kind of positioned near the point. Okay, so the normal vector is like about there. Okay, so it looks about right. Okay, that looks good. Okay, I think we're finally done. Only took almost 3 hours. Okay. And I guess it's a good spot as any to probably end the stream. Okay, so I was hoping that we would finish all of these diagrams. Okay, these two are pretty simple, but this one, there's a whole nother algorithm to try to do something similar for normal vectors. I guess that's what I'll be working on tonight. But I think yeah, this is probably it for now. Yeah, so this week is Thanksgiving in the US for people that live, I guess, not in the US. So I probably won't stream either Monday or Friday because Thanksgiving is on Thursday, and we'll probably be doing stuff with family, or for me, I'll probably be working some too. But so yeah, I hope you all have a great week. I'll be back on Monday at the same time, around 2:30 Eastern time, and I don't know what we'll work on by then. This video should be completed, so we'll probably work more on the URP HLSL shader, or maybe something, the next project, whatever that turns out to be. But yeah, I hope you all have a great week, and a great Thanksgiving for all you Americans, and yeah, I guess that's it. I'll put some links in chat if you enjoyed the stream and you'd like to connect with me on social media. I do have my YouTube channel where I have a bunch of game development tutorials. And I think that's about it. So have a great week, and I'll see you next Monday. Bye-bye.